I'm a PhD student at the chair of communication networks at the University of Tübingen in Germany. And I will show you secure OpenID Connect authentication for WebRTC. First, let me give you an outline. At first, I will introduce what WebRTC is, because I guess not everyone is familiar with that. Then I will show you a quick motivation why I want to do this. Then I will present you my proposed solution. Then we will come to a conclusion, and then we can go into a discussion. If someone has any questions, if I'm too fast or too slow, you can just raise your hands in Zoom and or interrupt me. That's okay. So at first, what is WebRTC? WebRTC is an open web standard for real-time communication. It is basically a collection of standards which are already exist in the IETF, but the collection itself was standardized by the World Wide Web Consortium as WebRTC. You could think of WebRTC as something like voice over IP or the session initiation protocol, but it is kept very simple so that it's easy to use in especially in web browsers. It is already widely used. For example, the video or audio telephony feature in WhatsApp, Microsoft Teams, stuff like that. Also in collaboration software like Nextcloud or OneDrive. OneDrive, I'm not sure, but it could be. Then also in gaming applications such as Google Stadia. Currently, when I looked it up yesterday, it was supported by about 95%. The only browser which does not support WebRTC yet, or maybe will never do, is the Internet Explorer. But all the major browsers today support WebRTC. So how does WebRTC work? At first, there are two clients, let's say web browsers or any native application which also implement WebRTC. They first generate an unsigned X509 certificate. So basically, it's just a public-private key pair, but in format of an X509 certificate. And these certificates are only used to identify this client or peers instances. So the WebRTC API is very restricted for security reasons, so that it's not possible to extract the public or private key of it or use this certificate for any signing or encrypting operations. The only thing we can do is to tell the web browser that he should use this certificate to establish a WebRTC peer-to-peer connection. And we can also extract the public key fingerprint of it. So it's the fingerprint is just the hash of the public key. When we extracted the fingerprint, we can combine it together with other information about the client, for example, its IP address, the public or the private IP addresses, and so on. We collect all of that information to a so-called session description, which we exchange via a signaling channel. The signaling channel could theoretically be every kind of connection which is out of band. We just need to reach the remote client. So we send our fingerprint and our IP address, how we can be reached, and so on. We exchange that over the signaling channel to the other client, and the other client does the same and answers with a session description answer. And then the session descriptions will be applied. And if that happened on both sides, then the WebRTC API will automatically try to reach the remote client, and they will establish a secure DTLS protected peer-to-peer connection. DTLS is just the UDP version of TLS. And the clients will then use their certificates to mutually authenticate themselves. At this point, the WebRTC API automatically verifies that the public key, which is provided in the handshake of this DTLS connection, corresponds to the fingerprint which was received via the signaling channel. Is that clear for everyone? If not, please interrupt me. Okay, so let's go on. Why I'm telling you this. Let's take this example. Alice wants to use her client A to connect to establish a peer-to-peer connection to Bob on client B. And this should be a direct connection with no other server which relays something or stuff like that. So now the question is, how does Bob know that this call or the client which he's communicating to is the client of Alice and not the client of, for example, Mallory? As I told you, the WebRTC security concept just thinks that clients can be identified with their certificates, but you know, randomly generated certificates cannot identify the user behind the client. So we have a solution for that, and that's OpenID Connect, where we can authenticate Alice and Bob. This is exactly what Slack is doing, but therefore Slack introduces two additional components. At first, Slack needs its own signaling channel, which trusts his own authorization server. So when Alice wants to authenticate herself with her Apple ID, and Bob wants to authenticate himself with its Google account, they authenticate via OpenID Connect to the authorization server of Slack. And so they will get a user account or a Slack account on the Slack authorization server where they authenticate with their identity provider too. And then the clients of Alice and Bob will get an access token from the authorization server, which authorizes them to access the signaling channel. So this requires that client A and client B both trust this authorization server of Slack. And not directly, but in the background, client B and client A should also trust the Google identity provider and the Apple identity provider, because maybe if there was a malicious attacker who has the Google identity provider under control, could maybe also authenticate as Bob. So in addition, Slack needs its own signaling channel because both clients will connect to the signaling channel and wait for connection requests from other clients. Thereby, they are authorized by their access tokens. And from the access token, the signaling channel of Slack also knows the user IDs of Alice and Bob. And the clients then must trust the signaling channel that when the signaling channel or the signaling server forwards such a session description from Alice, the signaling channel channel also must say that this session description offer comes from Alice's client. So Bob cannot verify if the session description really comes from Alice's client CA. He just needs to trust the signaling server of Slack that he will not provide any session description with another identity. So the signaling channel or signaling server also must be trusted. So my solution, which I propose in this presentation, says we don't need any centralized authorization server for that. We can do this only if we want to only do this for authentication purposes. We don't need any additional authorization server. The clients or their users can also individually decide whether or not they trust each other's identity provider. So in my solution, it's also possible that Bob says, okay, I don't trust this Apple identity provider, so I will not accept the identity of Alice because I don't trust this identity provider. In addition, we also do not need any dedicated signaling channel or any trusted signaling channel because we can verify the identity on our own. So now, how does this work? I will first give you a short overview, and after that, I will go into more details how this exactly works. At first, I have to say this is a solution which was primarily concepted for WebRTC. It could also be used in any other peer-to-peer environment, but so it may be adoptable, but this is primarily for WebRTC. So, okay. At first, what Alice and Bob need to do, they need to authenticate to their identity providers. In these examples, we will not use Apple or Google IDs. Instead, we will use another fruity identity provider, which is called the Apricot identity provider for Alice and the banana identity provider for Bob. So when they authenticated themselves to their OpenID provider, their clients will get an identity token, an ID token, which is bound to the WebRTC certificate of the client. So it's just like this RFC about the certificate-bound access tokens, but the ID tokens in this case will not be bound to an MTLS certificate, but instead to this WebRTC certificate. After that, they will exchange together with their session descriptions, which contain the fingerprint and the IP addresses. They will exchange their ID tokens in that. And then the clients will verify if they can trust this identity, depending on the remote user's identity provider, and the validity of this ID token. And so they can verify the identity of the user of the remote client on their own. After they check the identity token, they will establish a direct peer-to-peer connection and validate if these identities also match. So I will now go into more details how this exactly works. At first, we need to describe this authentication process. Therefore, the first step is to generate an WebRTC certificate. This can be done using the normal WebRTC API. So we generate this public-private key pair or X509 certificate. And then we will extract the fingerprint of it, because that's the only thing we can do using the WebRTC API. And then we will provide this fingerprint to the OpenID provider, which gives us an ID token that is bound to exactly this fingerprint. So this could be easily done by just putting it as a claim into this ID token. And that is the only thing we need to change on the OpenID provider side. Justin, you have a question.
Yeah, I was curious how, during what part of the process is this fingerprint provided to the OP? Is it part of the authorization or token request? Is it something on registration that's then bound to the client? Where does this come in the process? I'm having trouble seeing that.
In the token request.
Okay, thank you. So similar to the MTLS request.
Yes,
okay.
Of course. Yeah.
All right, thank you.
You could also put it in the nonce, right?
I will come back to that later, because yes, this also works, but there will come some problems with that.
Okay.
But I will go to that later.
Okay.
Okay. So in the token, for the token response, the OpenID provider just puts the fingerprint into the ID token and signs it with its own private key. And then he will issue it to the client. And this will be done for every client, for Alice's client and also for Bob's client. So same thing on both sides. Justin, you've raised your hand. Is there another question, or did you just? Okay. So the next step is the connection establishment. Therefore, we first need to generate an ID challenge. The ID challenge is just the hash of this certificate-bound ID token. Then we will transfer it via the signaling channel, which does not necessarily be trusted. The only thing we need to consider about the signaling channel is that he is able to reach the other client. When Bob received the ID challenge from Alice, then he does the same. He generates the ID challenge for his ID token and sends it back to Alice. Then the next step is the session description exchange. So then it's the same process as in WebRTC. The client generates a session description offer, which contains the fingerprint. But in addition, we put also the ID token, which is bound to this certificate, into the session description offer. Then Alice sends the session description offer to client B. Client B can then find out, okay, it's Alice who is calling, because that is inside the ID token. And then client B will do the same. He generates the session description answer, puts its ID token into it, together with the fingerprint and IP address and stuff like that. And then he responds with this ID token answer. Client A will then also perform a validation and apply it. So now, how does this validation work? Because it's not that trivial. So it consists of 4 steps, which needs to be done on every client. At first, they need to verify the ID challenge. So they extract the ID token from the session description, generate a hash of it, and verify if this ID token hash matches the previously received ID challenge. After that, they will perform an ID token validation, which works exactly the same way as always when we need to validate ID tokens. So it's basically just the JSON Web Token validation. And in addition, maybe if client B does not know whether or not he can trust this OpenID provider of Alice, he needs to look at some predefined policies, or if none of these policies, he should either reject the ID token or he should ask Bob whether Bob will trust this OpenID provider. Then we will come to the fingerprint verification, and this is where, for example, client B verifies if the fingerprint from the session description is equal to the fingerprint that the ID token is bound to. So now we know that this session description might come from Alice with a client which says that its fingerprint is what is quoted in the session description or in the ID token. Now the fourth step is we must verify that the remote client owns the private key of the certificate. And this is also the third step of the connection establishment. And this happens in the DTLS handshake. And this is done fully automatically by WebRTC, because, as I said, they will exchange their public keys in the DTLS handshake. Then WebRTC will automatically verify that the public key provided by Alice's client is the same, corresponds to the fingerprint received in session description A. That was a question. Checking the audience. Yeah, the audience. That's a problem in this part because we don't know the audience. Because the audience should be the audience for client A should be client B, but we don't know how to address client B. So at the current state of the draft, we will just input as the audience any group identifier like the application, the peer-to-peer application's name. Does that answer your question? Okay, I will go on. Okay. Yeah, so after that, the connection will be established, and that is implicitly the proof that the remote client owns the private key. And so the identity provided in the ID token seems to be valid. So to come to a conclusion, why should we do this? The main opportunities are that we can now perform a decentralized and federated authentication with OpenID Connect, and that not only in a client-to-server environment, but in this case, in a peer-to-peer environment, which is new to OpenID Connect. I guess there is no any other draft which also does peer-to-peer authentication of users with OpenID Connect. So the advantages of that is, as I told you before, Alice and Bob can decide on their own which identity provider of the remote user they want to trust. And we don't need a dedicated authorization server, which is trusted by every client. Also, we do not need any dedicated signaling server for our peer-to-peer application. And we also do not need any trusted signaling channel to exchange the session descriptions over that. So we could also use existing signaling or messaging systems like WhatsApp, Telegram, or stuff like that. And we can simply transfer our session descriptions via existing software applications. So why I'm standing here and presenting you all of that, it's because I need your help to make this to a new standard. What we need to standardize is the certificate-bound ID tokens. And I guess that's something for the OpenID Foundation where we could standardize this. Thereby, we need to add a procedure how to tell the OpenID provider that we want the fingerprint in this ID token. And that's just a recommendation of me. Maybe the format will in future be different in future. So I would recommend that we use this X509 thumbprint value as an HTTP post body parameter, and also add the algorithm that this fingerprint was generated with, for example, SHA-256. Yes, George?
Yeah, so unfortunately I'm time bound, but I guess other parameters that we have for OpenID Connect flows are sent at the authorization endpoint, right? So your nonce and other things that must end up in the ID token for verification go through that flow. And I'm just wondering if we couldn't use RAR, the rich authorization request, as a mechanism to define, the fingerprint values, and then it's just, so RAR on the authorization request is the way that they get into the flow, and then it's just a. All right, so Justin's contradicting me. I'll let him talk, because he was involved in what RAR is for. But I kind of feel like I don't know. My preference would be to put it in the authorization side, not at the token point where you're basically passing a code, but then trying to inject a bunch of other stuff into the flow.
Yeah, it was also an idea of me to do all of that in the access token. So do it on the authorization way. But I think it's better to split that up into the authentication part and the authorization part.
Right, but the ID tokens come back, at least in the code flow, come back from the token endpoint, right? But the data that goes into the ID tokens, some of that data comes from the authorization request itself.
Yes, that's just like if we put the fingerprint into the nonce value.
Conceptually, yes.
I have a slide for it.
I was thinking, okay.
I have a slide for it, and there's a good reason why I want to do it in the token request and not in the authorization request.
Okay.
I guess it's better if we jump to this slide, which I have prepared for it. Here. So, as Daniel asked me before, we could also put the fingerprint into the nonce value in the authentication request. Then this fingerprint will remain on the OpenID provider until we perform the token request, and then the fingerprint will end up in the ID token. That works. It is also but this is an unconventional use of the nonce value. It's valid. I guess it's really a standard conform because all the criteria are matched. The fingerprint should be a session individual value, which it is because the fingerprint is also individual to the sessions. And I guess the nonce should also be non-guessable, and that's the same thing for the fingerprints. But maybe this could collide with legacy implementations. I don't know if there's any application out there which also wants to use the nonce as a transfer of whatever. And the next thing, and I guess this is what you asked for. We need to perform 2 separate requests, and there we have some restrictions. For example, I guess in the authorization request, it's a GET request, and we need to put the nonce value as a query parameter. So the whole URL should not exceed 2048 characters. That's a restriction. I guess that's not a problem. But
well, I mean, there's other ways around that too. PAR, right, would allow you to post it first, which would add another request, but
Yep.
solve the URL problem.
Okay. Yeah.
I guess my question is the expectation then that you want to be able to use an existing refresh token, go to the token endpoint and get a new ID token? Because generally you don't get new, well, in many implementations, you don't get a new ID token on a refresh token request, right? And
Yes.
if it's a code, if it's the request that gets the ID token, normally that's a code because the user has just done an authentication.
Yes.
So, and I'm not saying it needs to go into the nonce. It could be another parameter into the authorization request, right? That is treated like the nonce, where, and that's why, Justin didn't like my idea about RAR, but to me, RAR is about saying, here's some additional authorization requirements for this issued, access token. And maybe that's where the disconnect is. But from a protocol perspective, it felt, it feels like this kind of data, because it needs to happen at the time the user is authenticating, because that's the time ID tokens are issued, we could use the existing patterns for getting data into the ID token.
Yep.
Was the thought.
That's a good idea, but the problem is we need to do this for every single connection. So for example, when I do a peer-to-peer connection with you and then to Daniel, then I need to perform both of these requests every single time when I do a new connection.
And that's fine. And so I'm sorry for interrupting, because I'm already late for another internal meeting that it's critical for me to get to. So I'll shut up and let you guys finish. To me, that's fine as long as we define a new grant type, right? So it's no longer the, right? So if we define a new grant type specifically for peer-to-peer tokens, then the definition of that grant type can say, all I need back is the ID token. I don't need an access token. And we can say, here's the extra parameters that go with this, peer-to-peer ID token request. That would also allow you to specify the audience if you needed to, right, in whatever specificity is possible, right, to get injected into the ID token.
Yep. I think that's totally fine. So we need to consider that we use another grant type. For example, I don't know, refresh token peer-to-peer or stuff like that.
Yep.
Okay. Justin, is there something else from you?
Yeah, so 2 things. One, I wanted to just explain why I don't think RAR is a fit here, and that's RAR you can largely think of as a replacement for the scope parameter. And so if this is a value that you wouldn't be putting as a scope parameter, you shouldn't be trying to cram it into a RAR object. So RAR is not meant to be a catch-all for additional parameters on the authorization request, nor is the claims parameter that's already in OpenID Connect, although I know some implementations have done exactly that with it. Regardless, the question about doing it as part of the authorization request is sound. It does absolutely have all of these problems that you're bringing up. The counterpoint, though, is exactly what George was getting at, and that's that you're getting away from kind of what most OPs and most clients really treat the ID token as, which is it's really intended to be a one-time message from the OP to the client, and to say this user is here now at you. And it's not really meant to be a
sent to another client. Yeah,
exactly. You're never really supposed to let go of the ID token, because there's also no guarantee. There's potential privacy issues with this, because there might be stuff in the ID token that I don't want Bob's client to know. Like my ID token might have my email address or something like that. And Bob doesn't need that in order for us to talk to each other. There might be an internal identifier that Bob doesn't need to know. Bob just needs a statement from my IDP in order for this trust to that's associated with this this certificate, this ephemeral certificate that I'm presenting, in order for Bob to be able to say, like, yes, this is the right person. The person that's here right now has been okayed with a particular identifier or whatever from this IDP, right? So I know that it's Bob, or Bob knows that it's me, rather. So I definitely appreciate how you're using the existing tools to kind of thread that together. It when you pull it all together, though, it really feels like it runs counter to what most of those parts are really meant to be used for, and what the assumptions and expectations about those parts are meant to be used for. So you start to very quickly get into territory of, oh, we'll define a new grant type. Well, then you've just thrown out the idea of making it easy for OPs to integrate this on top of other things, because now you're talking about a new grant type in OAuth2, which is functionally a new protocol for people to support that uses the OAuth2 structures, right? Every new grant type has a whole different set of processes and steps and limitations and implementation considerations that you need to get into. Like, just like some of them start at the token endpoint, some of them start at the authorization endpoint through the browser, some of them start at this whole new endpoint that's been invented. Like they're all very, very different from each other. So you very quickly get into just making up a new protocol space that really doesn't look like OpenID Connect anymore. That said, I'm not trying to disparage this work. I think that this is a really clever way to sort of pull the parts together. I just think that it's when all together, it might be more fragile than it seems on the surface.
So you think it's a good idea to do it, but we should do it so that it's clearly a different protocol.
Well, I mean, either go full in with all of the sort of assumptions and backing of OpenID Connect and say this is OpenID Connect and works inside of OpenID Connect, which may or may not be possible with what you're trying to solve here. Or just take a step back and say, this isn't OpenID Connect, this is a protocol that's being used to connect these keys and stuff like that, which I will say at this point, this is similar to what some people are deploying GNAP for, this whole key introduction between not peer components, but clients at the same level within the system that are generating and introducing ephemeral keys. GNAP has the benefit of having always starting with a back channel post to the AS to start this off, and having a more sort of tightly defined API for updating things over time. So there's no refresh tokens because you're just rotating tokens or updating grants, or there's sort of more specific actions that you can do. So this notion of, I need to get this special assertion back from the AS in order to do this, and I want to do that at a point where the user has already been logged in for a week or something like that. That's something that you could more easily define in there. That said, Apple and Google and all of these guys are not going to be supporting GNAP for a long time, probably.
You also mentioned that there could be issues when a normal ID token will be issued to another client, because that could leak any internal details. That's also a reason why I think we should create a dedicated ID token, which is especially generated for sending it to another client. So the claims in this ID token should be different to that ID token which was issued to the client to stay on the client.
Yeah, it's you're getting closer to a token exchange, and in that you're exchanging it for an assertion to hand to somebody else. And you know, if you wanted to stay within the OAuth2 world, then that's something the token exchange RFC could potentially help with. But you know, again, it's designed to go cross domain like this, but again, it's a little it's still a bit different. It's still a bit off label, and you're not dealing with ID tokens and identity so much. So you would have to define the frameworks around that. If I may, while I still have the mic line, I also wanted to say that I really like this, the general scope of this idea of attaching, I'm going to call it attaching an individual authenticator to a session. Because this is something that in my work with NIST, we've struggled with the definitions in NIST Special Publication 800-63, which defines a holder of key federated assertion profile. And that boils down to being able to present a certain class of authenticator at the same time that you're logging in to the client. One of the missing pieces that unfortunately kind of died along with token binding and some directions that the FIDO group took is this ability for the client to introduce back to the IDP. You know, this is a fingerprint of an authenticator that I have verified that that I want you to associate with this account. That sort of upstream reintroduction is something that none of the existing federation protocols have right now. And I would love for there to be a general version of this that works even beyond just certificates. I think certificates is kind of a, the lower hanging fruit version of this because they can be independently verified, blah, blah, blah. But I think that you could do this with all sorts of different types of authenticators. Because the real trick is exactly this upstream push of authenticator and key information back to the IDP.
Yeah. Okay, thank you. Then I will go on with the presentation. It's not that much. We also need to specify how to put the fingerprint into the ID token. And there I recommend to do it the same way as this MTLS draft or RFC for the access tokens. We add a confirmation claim, which includes the X509 thumbprint as in this case SHA-256 encode as a SHA-256 hash. And then we put the base 64 URL encoded fingerprint here, which we should. Brian, there's a question from you.
Yeah, I'm sorry. There's probably a lot I'm not understanding here, so I apologize if this is ignorant or wrong. But if you're doing this at the result of the token endpoint call, why parameterize it, and why not just make that a mutual TLS authentic connection and pull the content directly from the certificate presented on the connection?
Because we can't use MTLS to establish the peer-to-peer connection.
But this isn't.
Oh, you mean we could? Yeah, we could also do it the same way as the MTLS.
Yeah.
But then we need to establish a connection between the client and the authorization server with WebRTC, and that's a very huge implementation effort. Does this answer your question, or is it not that clear?
No, but it might be my own misunderstanding. You've got a request to the OP's token endpoint here, which is HTTPS.
Yes, and we pass the fingerprint of the WebRTC certificate
As a
but
parameter.
as a parameter.
Yeah. And
If I may, Brian, I think that where the gap might be here is I think these I think Jonas is trying to do this from JavaScript in the browser, and JavaScript can't initiate HTTP connections with MTLS.
Oh, that would explain it. Okay, that makes that.
And in
That answers my question at least.
Yeah. Okay.
Thanks.
Then the next thing we need to specify is we need to encode the ID token into the session description. And I found an RFC of Mozilla where they added the identity attribute to the session description protocol. And I think that could be a way how to put the ID token into the session description protocol. Yeah, and I guess this question is also solved now. I wanted to ask Justin if it's possible to adapt this for GNAP2, because I think it would be not that good if we just implement it for OAuth, but also we should do this for GNAP. Justin, do you think this is already possible with GNAP, or do we need to define an extension for it?
So I mean, you would need to define an extension because you are looking at presenting a separate key from what you're looking to use for authenticating the client call itself. So basically echoing Brian's previous query. Because right now GNAP has a way to say like, oh, this is the key that represents the client, but you would want to have another field that says this is the key that represents the client's WebRTC. That's a small extension, but you would want to put that in a different place if you're not just reusing the MTLS signature kind of thing. The other thing is that GNAP does not itself, like OAuth, GNAP does not itself define any sort of returned assertion formats. It gives you a place to request them and a place to put them. But this would be a sort of another kind of thing that you would be asking for back. I do think though that it gives you a better base for defining something new, because you're no longer trying to say like, give me the ID token that's not actually an ID token so I can use it not like an ID token. You're saying in GNAP terminology, give me an assertion about the current subject in this particular format and profile. And that can be defined by this WebRTC work to say that, you know, when you ask for this piece in GNAP, this is what you get back and here's what you're allowed to do with it. Right now, what GNAP does is it points to existing identity protocols, including OpenID Connect and SAML2 for well-defined existing assertions about the current user. And that is explicitly extensible for exactly the kind of thing that you're doing. So the short of it is that, yes, I do think it actually makes, it fits well with GNAP's model, especially because it is intent registration based. So you can put kind of all of this extra information into that initial request, but you would still have to make an extension for it. Okay.
So in general, it would be technically possible to do what we need to additionally define here for OAuth. This would be possible in GNAP right now, but we should specify it how this should be handled. Okay.
Yes.
Yeah, that's all of my presentation. Do you have any other questions or something like that, Richard?
Yeah, hi, I'm Richard Barnes. I used to work at Mozilla on WebRTC, among other things. I now work at Cisco on WebEx.
Okay.
So this is really good work. I think you've made some really good progress here. I think you might be, it might benefit you to look a little further out in the future. If you look at so I think the idea of adding authentication to end-to-end adding end-to-end authentication to things like WebRTC is a really valuable idea, and it's something I think folks are interested in the industry. But I think where most folks are looking when it comes to end-to-end security is not so much at the WebRTC layer with these point-to-point connections, because in a lot of cases, there's a media server in the middle. In a meeting like this, there's a giant media server in the middle, probably several, through which our media is traversing. So what we really need is an end-to-end key negotiation, which folks are doing in a couple ways, using MLS and some other tricks, and using S-frame as their extra encryption there on top of WebRTC.
Okay.
So I think you might take a look at some of those end-to-end technologies and ponder like how a system like this could extend to that, as opposed to the more certificate-based framework that WebRTC has. But I'll ping you offline. I'm happy to have some conversation about this.
Okay, so you mean it would be a good thing if we do the end-to-end authentication not directly for the peer-to-peer connection, but for the end-to-end connection. If, for example, as you said, a media server is in the middle, which relays it to other peers. And so we need to authenticate the data which is put through this WebRTC connection.
Precisely. I think the solution you've got here works probably pretty well for those point-to-point WebRTC connections. But the observation here is that in practice, not much WebRTC is done point-to-point in that way. It's usually relayed. So yeah, there's some solutions out there for how you do encryption on that end-to-end basis. And then the question is, how do you take the key exchange for that encryption and add this authentication to it?
Okay, good point. Yeah, thank you for that.
I'll send you an email and follow up offline.
Any other questions? Justin?
Yeah, not a question, but more of a suggestion. You had said that you were looking for help getting this into the standards community.
Yes.
And honestly, the best way to do that is to write it up in some standards document format. Take your pick. If you want to target IATF, at least for an initial draft, go to do XML to RFC type stuff. There are markdown tools for doing that, and just write it up in that format. If you're doing W3C, go learn how to do remark HTML insanity. And
I've already started to do it in Word.
Okay.
Yep. You see it on my screen?
Yes, I do. Okay. So there's specific reason that I'm highlighting the tools is that if you bring a Word document to any of these standards bodies, most people are going to not read it. So translation of this into sort of standard space type of format at the very least tends to be the first hurdle for most of the standards orgs. It's kind of a, if you're willing to come put it into our document format, then maybe we'll keep talking to you kind of thing. It's kind of the cost of having a conversation, I've found anyway.
As a standard, someone who spent some time in standards, I might slightly disagree with it. I think a well-worded email with a pointer to a good write-up can go a long way, but yeah, you'll ultimately have to cross that bridge.
That Richard makes a really fair point, and that's introducing it into the spaces in a way that is publicly available, on in a website or a PDF or something like that. Again, not a Word document ultimately, but some readable artifact does help. But what I was really trying to say is that if you are serious about moving it in a particular community, you do have to cross that bridge of translating it into that community's favorite format in order to really have that conversation.
Yeah. in OpenID Foundation, what would be the best format? A Markdown document, which is uploaded to GitHub, or?
So OpenID Foundation uses the same XML to RFC toolchain that IETF uses.
Okay.
Last I edited in that space, so hopefully somebody can correct me. It was a different. It was the HTML that was the canonical version and not the text version, but
Okay.
that may have changed.
Okay. David, thanks to that comment. Do you have a link for Vittorio's blog? Okay, thanks. Yeah. How would we continue? Okay. Thanks, David. I will upload the slides as a PDF to the Slack channel. And Justin, could I contact you when I am starting to put the standard to OpenID Foundation?
If you like, I'm not sure how much help I'll be with
Okay.
that. But
Okay,
I mean, feel free to.
Okay.
I would also be happy to help out with that, Jonas.
Okay, thank you.
Yeah, to echo Richard's comment earlier, I agree that this is good work, that this is a really interesting thing for from both. You're hitting an intersection of technologies and problems where I honestly think it's interesting from both directions, both from connecting peer-to-peer and from augmenting the authentication process.
Okay, thank you very much for your feedback.
Thank you, Jonas.